So you've now already learned about what compose state actually is, what its purpose is, how we can hoist state and why we should hoist state to actually keep our composables free of state mutations. So you've seen this here with a state hoisting demo example where we hoisted this counter state out of this counter composable in order to completely control how we want to actually change this counter. So we can also use this and repurpose this for multiple composables at the same time. However, you have also already noticed that if we have a more complex app with possibly 10, 20, 30, 50 states just for a single screen, then this approach of just putting these states here in our composable functions at the very root will become very messy. And also there's no really clear place where we actually want to update this state. And that is what this video will be about. I will give you a clear roadmap how I suggest you to manage your compose state, how to update it, how to observe it with an approach that scales and that works for any type of project. And specifically as a little practice again, this left app here is what we will build in this video, a simple number guessing game where we will randomly generate a number between 0 and 100, and then we can guess the actual number. So we can say, okay, is it 50? Make a guess. Nope, my number is smaller. Okay, let's do 25. My number is larger than 25. So let's try something like 35. My number is still larger. Let's try something like 43. My number is still larger. I don't know, maybe 48. Smaller, 46. Nope, 44 and 45 it probably is, yes. And then it says, okay, you needed 8 attempts and we can start a new game. If we click that, then it just starts all over again. So on the screen, there's obviously a bit more happening now than just a single state that is being updated. So we'll take this as an example to show you how real world state management should look like. And to get started, let's go to our project and actually go to state management. And here I want to just create a package, guess, or number guess, like this. And the approach for state management that I will show you here will actually be part of the so-called MVI design pattern. So that stands for Model View Intent, which is a presentational architectural design pattern. And it pretty much just tells us how we separate our presentation layer. So everything around visuals in our app, how we separate that so that we have clear responsibilities. For on the one hand, just displaying and rendering state on the UI. On the other hand, for managing the state and also to update the state with certain logic. And the way this works is, in our number guess package, we will have something like a number guess screen. So no matter what kind of app you will build, every single screen in your app will get one such screen composable. This will be a file. In here, we can create this number guess screen then, which then holds the actual UI. So we can also add a preview so you can actually see what is happening here. Number guess screen preview. We say, okay, Jetpack Compose Masterclass theme. We add this number guess screen, and we also give this preview a background, just as usual here. But before we go on with actually implementing the UI, I want to think about which specific things can actually change on that screen. So let's go through the game again. So you can see we have a text field where you can actually type something, but ideally only numbers. This current text of the text field is definitely a value that can change over time. It's a string that can change. So that must already be part of our state. If we then make a guess, then here's something that actually dynamically changes our UI. So whether we want to show this text or not, or rather which text we want to show and if we want to show it. Because this text could be, okay, my number is larger, my number is smaller. It could be, yes, you guessed the number. Or it could just be null. So then we don't show any text at all if we haven't made our first guess yet. If we then guess the right number, that also needs to be a state, because then we want to additionally show a button here in order to start a new round. Those are at least the states that we need for this that are visual, but we'll get to some more states we need in a moment. But the way this works with MVI is that after we've thought about all those states that we want to have on our screen that we need there, we bundle them in a data class. So we will create a new class here called number guess state. And this data class just bundles all those single fields that could change on our screen and have an impact on our Compose UI. For example, our current number text. So the current string that is in our text field. So here, for example, 25. Then what is dynamic is this specific text here that is displayed after we've made a guess. So we could call this a guess text. which is a string that is nullable. Why is it nullable? Because there's also a scenario where we don't want to show this text at all, when we haven't made a guess yet. And as we've said, we do need a state whether our guess was correct, which is initially false. If this is true, then that means we want to show our additional start new game button. So this is now the approach that the MVI design pattern takes, that we just bundle one screen state into such a data class. And you'll see in a moment why this is really useful. But the question is now, where do we actually store the state? I mean, if we took a look at the last video about state hoisting, we could of course put the state here in our compose UI, just like this, with the difference that we don't have a mutable in state, but we would have a normal mutable state of, in this case, of a number guess state. This would, of course, work. In this case, actually not, because remember, Savo only works if the value can be stored in a bundle, which this state by default can't, unless we make it a parcelable and that kind of stuff, which is not what we want to do here, because this whole topic that state also needs to survive configuration changes like screen rotations, that is just one part of the equation, or of what we need to think about when it comes to the right state management. The other part of the equation is that we also just want to have a clear place where we just have our logic that is responsible for updating state. Because if we have that logic in one place and our pure UI, which really just listens to the raw state updates, then we've really isolated these two. Because if we then have some kind of bug or so that is relating to how a state update happens, we know where to look for that. We don't need to look and deep dive into our composables because our UI displaying is mixed with the state updates. No, we actually need a single place to look. And the place where we want to do this is in a view model. Maybe if you've worked with Android before, you will know what a view model is, but we also want to use that in Jetpack Compose projects. So as the name says, a view model is really just a model for the view, so our UI, and it contains on the one hand the state, so a reference to the state, and the logic to update it. And it, of course, also receives these user actions, so what a user can do on a screen when we click a button, when we change a text field's value, when we long click on a button, when we, tick a checkbox or so. All these kinds of actions we will then send from the UI to the view model. The view model will then process these, possibly update the state, which the UI will then, again, observe and reflect the changes. So here in number guess, let's create a new class called number guess view model. That will be a pure class, and on Android, these inherit from view model. I will actually link down a separate video I made about view models specifically, why we use these on Android. I don't want to dive into that here, because I've made a very detailed video about view models, configuration changes, and all kinds of stuff. So I also don't need to bore you here with view model stuff in case you're already familiar with that. But the way this works is, in here, we will now have a private val that reflects our actual screen state. And we now have multiple options to actually store the state. We could, of course, say, we actually have a private var, or rather a public var, we call state, and we say that is by mutable state of, and we pass in our number guess state. I'd enter to import this delegate, and we will say private set. So what this will achieve is that just the view model is allowed to change the state, to access the setter, but the getter of the state is actually public, so we can observe it from the UI, but not change it directly from the UI. That's usually what is desired with view models. So you can notice this is how we could store a compose state here in a view model. And this would work out of the box if a composable would now observe the state. We don't need to remember here because we're not in a composable function anymore, so that would work as it is. The alternative is that we use something like stateflow, which is also commonly used to store UI states. Here we can't use this private set, but here we need to use two separate properties. On the one hand, underscore state, which is typically the private variant, a mutable state flow, and we also pass in our number guess state in here. We then have a public immutable version of this state, which we expose with state as state flow. And in Compose, we also have extension functions to actually take a state flow, which is nothing else than an observable data structure that holds a reference to state, just that it works with Kotlin flows. But in Compose, we have extension functions to actually take this and convert it to a Compose state as it is. Because in either case, Compose definitely needs to work with a Compose state that tells Compose and all of our composables the changes. What kind of state type you pick here is in the end a matter of preference, but I personally prefer state flows since they allow us to do exactly the same as compose state, but more. So we can add reactivity to that. For example, if we say whenever our email text field changes, then we automatically validate the email and automatically update another state that maybe shows a check mark if the email is valid and a cross if it's not valid. These kinds of reactive things we can do with flows, which I teach in detail in my coroutines and flows masterclass. And state flows make it easier for us to actually update our state in a thread-safe manner because they just provide functions for that. So that is why I will kick out the compose state here and rather work with a state flow. And if we now go back to our composable, our number guess screen, then we can get a reference to this view model in here by saying val view model is equal to view model. This will simply be a number guess view model. So this view model function here is a composable function, so it's safe to call this in a composable, and it will simply initialize a reference of our number guess view model and bind this to our current screen in the app. And from this view model, we can now retrieve our state here in this number guess screen. So let's do that. We get our state, and the way we can observe this, since this is in the end a state that comes from a state flow now, so we have our view model as a state, you can see this is a state flow, not a compose state. And in order to convert this state flow to a compose state, we can call collect as state with lifecycle. So there's a function which actually comes from a separate dependency you have to include. That is what I already did, but just to show you that in case you're not aware, in our version catalog here, I have added two dependencies. On the one hand, Android lifecycle runtime compose. This is where the collect as state with lifecycle comes from. And this view model compose is where this view model function comes from in order to get a reference to a view model in compose. So in case you don't have these dependencies in your project, then you can of course copy paste this from below, or maybe you're working on my repo anyways. But we can then say, we collect this flow as a state with lifecycle. You can see there are two versions of that, collect as state and collect as state with lifecycle. On Android, we always want to use the collect as state with lifecycle, since that is lifecycle aware. It works with the Android lifecycle, with the activity one, with the fragment one, and also makes sure that the underlying flow does not keep on processing any operators, any functionality, if our app goes in the background. You might wonder, why is there still collect as state? Well, because Compose is not a UI framework specific to Android. There's also desktop, there's multi-platform, where this concept of a lifecycle not always exists. So in that case, we would use collect as state, but on Android, collect as state with lifecycle. And here we can also make use of the delegate, because right now we would get a state, a Compose state, of type number guess state, which we would always need to refer to with that value. We don't want to do this, so we can replace this with a by, Alt-Enter to import this delegate, and then we get this number guess state as it is. So whenever any field of our number guess state data class, changes, this value will update. And we can now, of course, use this value in our UI here when building the screen. However, there's one problem with this approach if we just do it as I've shown you here. The thing is, we kind of couple our number guess screen to this specific view model instance and also to the way we initialize it. And right now, if we, for example, just display something, let's just have a column here with a center text for now. Modifier is modifier fill max size, and actually refer to the modifier we passed here. We can say horizontal alignment is center horizontally, and let's say the vertical arrangement is arrangement spaced by 16 dp, Alt-Enter to import dp, and we say want to still center our content vertically, so alignment center vertically. And here we will then have a text where we just display our state dot, number text, for example. Now let's actually just change the default value of that so we get to see a real text. So here in our number guess state, let's say the number text initially is some kind of number, that doesn't matter for this demo. If we then take a look here in our preview, build and refresh, so we can see this. Okay, I actually broke the code here. Let's revert this to, I think I can do it like this. Revert this to mutable int state off. You probably did not get this. If we go back to number guess screen, take a look here, build and refresh again, then we get to see our string here. So far, so good. But the thing is, the moment our view model has a constructor argument, something like, just a test string, for example, the moment it needs some sort of class instance, some sort of dependency, which is very likely the case when you work with view models in the real world. And we then go back to our number guess screen, it's loading, and if we refresh this, then you can see we get a warning here in the file. Then it still displays something, but let's change this value to something else. So we see if it really reflects those changes, and you can see it doesn't. It still shows the previous value because the preview now can't update anymore because it doesn't know how to create this viewModel instance given that it now needs a constructor argument. It doesn't know what the string is. And in the real world, we often make use of things like a dependency injection framework like Coin or Dagger, which dynamically inject those dependencies, those class instances here, into viewModels, but the Compose preview is not smart enough to do that on its own. So the moment you actually make use of a viewModel reference inside of a composable screen, and the viewModel also has certain constructor arguments, then the preview becomes unusable. You can't have a screen-level preview anymore because it's coupled to this viewModel. And because of that kind of a problem, the screen structure that I always use is that I introduce a separate composable for the screen, which we call number guess screen root, so the root composable of that. And this is the place where we keep track of our viewModel and state. And other than that, it really just calls our actual screen, so the number guess screen. We can then also forward the modifier here, and the number guess screen, of course, now needs a reference to the state. But this way, we can really just pass down the state without needing to pass down the viewModel. So if we do this, state, number, guess state, like this, we then go to our root composable and just pass down our state. Then there is still an issue here with the preview. But now for the preview, we can just pass in some kind of state instance that we want to preview on the screen, like a number, guess state. And we say, okay, the default value can stay that, but you can already see now the new change is actually reflected because now the composable we are previewing does not rely on creating this viewModel anymore. So we really just have this wrapper composable, which is just responsible for creating the viewModel, for listening to the state, and other than that, just passing that to our number guess screen, which is now completely isolated from any type of viewModel. So that is why I can only recommend to have this kind of structure for every single compose screen in your app. But let's now move on. Let's actually start to implement our screen because we will experience another problem. If we go to our actual UI, and the first thing that is here inside of our column is our text field. So instead of this text, let's create a text field with a text field composable, which now needs this value, which is simply the string that is shown in the text field, like the 25 here on the left side. The value we can get from our state now. That is, of course, dynamic. So we can say state.number text. Then what we also need to pass is this onValueChange lambda. So this is a lambda that changes whenever we type something in this text field. So we get the new text. And now we, of course, need to do something with this new text when the user types something. So we would, of course, need to update the existing text so that the new text, after updating it, also gets reflected on the text field. So how do we do this? Well, we could, of course, provide a lambda, just like you've learned in the last video, that we have something like an onValueChange we use here, which gets a string, and we then just hoist this new text to the parent composable, which has a reference to the viewModel, could call a function of the viewModel to update the state there. That would work. But the larger your screen gets, the more such little lambdas you will have to add here. And that is why the MVI pattern works with a so-called intent part. So that is what the I stands for in the MVI pattern. It's the model view intent. And the intent part is really just in Kotlin a seal interface that bundles all those different actions, all those different things a user could do on the screen. Clicking a button again, changing the text field value, and so on. And we just bundle these in a single sealed interface. So we just need to pass one single lambda per screen in order to bubble up these actions. And the way this works is we go to our screen again. We create a new sealed interface called number guess. I call them actions. Some people call them events. I call them actions. We make this an interface, sealed one. And in here, we now outline all those things the user could do, the user could initiate with an interaction on our number guess screen. So specifically, that's on the one hand a data object, which is called onGuessClick, which we send to the viewModel as a result of when the user clicks on the guess button. So this is a number guess action. We then want to have a data class, which needs an argument, when the guess text changes on, let's call it, on number text change, where we get the new number text, which is a string, which is also a number action, number guess action. And lastly, we need a data object, which again does not need any parameters, when we click on the Start New Game button. number guess action. So for all these things the user could now do on the screen, we have one of these actions. But given that we now bundled these as a CL interface, we just need to send one instance of the CL interface, so either this, or that, up to our parent composable, which can then forward these to our view model, which handles these events or actions. Sounds very complex. It actually isn't once you've understood it once. Let's take a look at how this works. So instead of providing this on value change here, and then also an on guess button click and an on start new game button click, we just want to provide a single on action lambda when any type of action happens. So that will be a lambda that takes an argument, specifically a number guess action now. And that is the only lambda we need for this screen composable. If we then go up to our root screen and we hop into our view model, this view model now of course needs a way to handle these types of actions and respond to them with a state update, for example. So we have a function in here called onAction, where we receive such a number guess action. And here we can then simply have a when expression in order to unwrap these and check which specific action it was now. And depending on the action, we might want to just have a different state update, of course. So we can hit Alt-Enter here in this when branch, say add remaining branches, and that way we can say, okay, if the user clicked on the guess button, we want to do this. We want to update the state in this way. If the user actually changed the text in the number text field, we want to execute this code. And lastly, if we want to start a new game, then we want to execute this code. And that way, what we can now do is we can go back to our number guess screen. This now obviously here needs this onAction lambda, which we currently did not provide. But since the signature of this onAction lambda matches the one from our view model, we can really just say onAction is view model : onAction. So this will really just forward all the actions we've sent with this lambda here directly to our view model reference. And that way we can again keep this screen completely isolated from the view model reference. If we really just look at this screen without the rest of the file, then we don't even know that it is using a view model behind the scenes. And that is what we want. We want to keep our UI as dumb as possible. That is how we call this. We want to avoid putting real logic in our UI, but rather just give the UI exactly the state to render. And when something happens in the UI, like an action, then we just want to bubble these up. That's really all about it. So now, instead of calling this onValueChange lambda we had previously, we want to say onAction instead. And specifically, we want to create a number guess action dot, in this case, onNumberChange, because that is what happens here. And we pass in the new text. This will then be bubbled up to this composable here. This will trigger. It will send this onTextChange action to our view model. The view model will then receive this. We'll check, okay, what type of action is it? Okay, it is actually a number text change action. So in here, what we can then say is we update our state. So state update. And we say it.copy. So it refers to the current state. We create a copy. Same reason as I shared before. If we have state in a data class like this and want to update this, then we need to provide a whole new instance of that state. Otherwise, that won't trigger a change in our composable. And what the copy function will do is it will just create a new instance while allowing us to change individual fields, like this number text, for example. And we simply set it to the new number text we got from this action. And this way, we have already implemented a fully working state management system. We need to fix our preview because here we don't have this onAction lambda that we provided. But in the preview, we can really just leave this empty because the preview is just for previewing purposes and not to showcase any functionality. But we can already test this by actually taking this root screen and now adding this to our main activity instead of the hotel booking screen, of course. So here we can say number guess screen root, this one here. We give it some padding, modifier padding of our inner padding. And if we then launch this, we should already be able to see our text field and also input a text. Okay, I did this. My app actually crashed. Let's take a look at why that is. No such method exception. Yes, because of course, we still have this constructor here in our view model, and we did not provide a way to actually pass this. We don't need this. This was really just for demonstration that in the real world, you often have these parameters where the preview does not know where these come from, but your actual production app knows that because you're using some kind of dependency injection framework. We don't have either of that, so we just leave it empty, and then Compose will know how to initialize this. So here we now have our initial text field, as you can see. It has our initial state, but we are free in actually changing this text. We can type something here, and this only works because of this state update line. We receive these number text change events, we update the state will then be converted to a compose state here with this function. Since it now is a compose state, it is able to tell specific composable functions that a change happened, that they need to also update. It will be passed down here. It will look for exactly the composable function that makes use of a field of the state, which will be the text field. Okay, it actually makes use of the text, so the value of the actual text displayed will also update. So this is the whole idea behind this type of state management system with MVI. This is not the only way to manage state. Some people like to use MVVM, some people like to use MVC. So there are different design patterns, which all in the end have the same idea, the same purpose of just separating UI from state updating logic. But for exactly the reasons I mentioned here, that we just have this bundled state and these bundled actions that we need to pass to the composable without providing all those single state values and single lambdas, that is why I like to use this pattern. But we're of course not yet done with implementing our functionality. So let's do that. And next up, below this text field, we need a button in order to just make a guess. When we click this button, we can now say, okay, we send an action. That's again a user action. And that action will be number guess action on guess click, since this is our guess button. And the text will be make guess. Something like that. Then below this button, we want to have our actual text that says my number is actually larger, my number is smaller, that was the correct guess, or just nothing at all. And that is dependent on whether our state guess text is actually not null, because only if it's not null, if there is a specific text we've set, only then we want to display the text composable. So we can say text, where the text is simply our guess text. That's also state, also dynamic, and can therefore change this text. And lastly, below this if statement, we want to check if the state guess is actually correct. So if we made the correct guess, then we want to display an additional button in order to restart the game. So we can say button on click. Here we want to say action, number guess action on start new game button. Click, it should actually should be called. So let's rename this to on start new game button click. This is in general how these things should always be called, these actions. Never call them in a way that kind of contains information about what you expect as a result of that click. So in this case, it should not be called number guess action start new game, but rather what happens in the UI, and then leave it up to the view model to decide about what you do as a result of that. In this case, this does result in starting a new game, but sometimes it's not so obvious. And if you just send these types of actions or what actually happened on the UI without implying what happens as a result of that from the UI to the view model, then you're more flexible in also letting the view model handle these types of actions. So here for this button, we have a text, start new game. And that's already our UI. We can of course pimp this text field a little bit, make it more user-friendly by only allowing the user to input digits without any letters. We can do this with the keyboard options that we pass here, keyboard options, and passing in the keyboard type as a keyboard type, that number. But everything else, now that we have our UI, happens in the view model, because we of course still need to respond to all these events and actions, which we just did for when the number text changes. So when we click on the guess button, what happens? Well, the view model, of course, needs to validate and verify that guess, needs to check, did the user guess the right number? And in order for the view model to actually do that, we of course need a random number to be generated in the first place. And that random number is also state. It's a value that can change over time, because when we start a new game, we will regenerate a new random number. However, that random number that we generate does not have a direct impact on our compose UI. There is no composable in our screen that directly displays that random number. And that is why it's still considered state, but does not need to be compose state specifically to tell our compose UI changes. So we can simply go ahead and say that is a simple value, a simple var, private var, number for example. And the initial value is random, next integer, and we provide a range from 0 to 101, because the until number is actually excluding, so we effectively get a random number between 0 and 100. Let's actually do between 1 and 100. So this is the initial random number. What we also want to keep track of is the amount of attempts the user has needed to guess that number. So private var attempts is equal to 0 initially, and same reason we don't include this in our number guess state, because we don't really need to show these attempts in the UI. I mean, indirectly we do that in our text, but since our our guess text here is already part of the state, we can of course update it in a way that includes the number of attempts. So the number itself does not need to be a state strictly, or not a composed state strictly. It's still state. So here in onGuessClick, we first of all want to take the actual string that is currently in our text field, so here, and convert this to an integer. So we can say val guess is equal to our current state, that value, to get a value of this current number guess state instance, and check if the number text, actually not check, but just refer to the number text, and convert this to an integer or null. We definitely also want to say attempts plus plus. So we just say when we click on the guess button, then we made an attempt. So we need to increase this. And after that, we can change our state again. So state update it.copy. And here, the guess text can now change, of course. Specifically, there are a few scenarios that could happen. On the one hand, that our guess, the actual number that was guessed, is equal to null. This would be the case if we click the guess button, but the user did not input any number, for example, so this conversion would fail. In that case, we can map this guess text to please enter a number. And we actually also only want to update these attempts if the user did input a valid number. So if guess is not null in this case, then we want to update those attempts. But there are more scenarios. Another scenario is that the number that, the random number that we generated is actually larger than our guess. Then we can say, nope, my number is larger. If the number is smaller than guess, we say, nope, my number is smaller. And in all other cases, if it's not larger, if it's not smaller, and if we made a valid guess, that means we definitely the right guess, of course. So here we can say, that was it. You needed attempts. So this is how we can conditionally now update our guess text. We want to update more states of our bundled state, because when we made a correct guess, we also want to update this is guess correct boolean. So is guess correct is equal to guess being equal to our number. And lastly, when we made a guess, we want to also reset the number text, so we want to clear our text field, which we simply do by setting it to an empty string again. And when this is now true, is guess correct updates, our new game button is being shown, and when we then click it, this will be called. So here, we also want to update our state. And when we start a new game, let's think about what this means for our state. Our number text should definitely be cleared. Then the guess text should be reset to null, because when we start a new game, then we did not make a guess initially yet, so we don't want to show this guess text. And is guess correct is false again, because then we just generate a new random number, which we of course have to do here. So we need to say our number is now again a random number, random next int, from 1 to 101. And by the way, when you work with these state flows, always make use of state update, because there's also underscore state value is equal to something like state value dot copy. This also works, but state update is actually the thread safe variant. So especially if you work with multi-threading in your view model, which we currently don't, but then using state update will do a thread safe update, while the other one can lead to race conditions. That's, as I said, one reason why I prefer state flow, since composed states by default don't offer that without taking any further care. Okay, that's our view model. Let's go back to our number guess screen. And I don't think we actually need to change anything here. Let's actually rather launch our app and take a look if this works. So we have our initial state, which we can of course change back here to an empty string in the number guess state. If we then relaunch this one last time, hopefully, we can input some numbers here. You can see we can now only see our numbers. Let's start with 50 again. Say make guess. It says nope, my number is larger. Okay, let's try 75 next. Number is still larger. Let's try 88. So a good old binary search. Number is smaller. Okay, so let's try 82. Number is still smaller. Let's try 78. Still smaller. 76 maybe. Yes, that was it. Needed 6 attempts. We guessed the number. And if we now start a new game, we get a new random number. So you'll notice this if we now type 76 again. That won't work because we now have a new random number. Awesome stuff. So this is how I really structure all my screens, all my composables together with their view models to have a proper state management setup. Just one last thing here regarding this approach, because that is a very common question. If we bundle our state in such a data class. And with a state update, we always have to change the instance, so generate a completely new instance with copy. And you've also already learned that if a specific value, a specific compose state changes, then compose will look for all composables that use the state and recompose these. So does this mean that if we, for example, update our number text, which definitely creates a new instance of our state with every single keystroke, does that also cause recompositions in composables that don't use this number text because the underlying state's still updated? There is still a new instance of that. So for example, does our guess text recompose because the state still changed? Like the state as a class, it's a new instance in the end. And the simple answer is no. Luckily, Jetpack Compose is smart enough to detect field changes of a data class individually. So if our number text actually changes, even though it is part of, in the end, a single compose state, only this text field will recompose and not the remaining composables that use fields from that state class. So that is definitely something you don't need to be afraid of if you stick to this approach of state management.